The next problem gives us a situation where some quantity A is said to be proportional to the square of R. And I think maybe there's an interpretation that A is the area and R is the radius or something like that. In any case, A is proportional then to, A is equal to KR squared, because P is proportional to Q means P equals KQ. So if it's A proportional to the square of R, then it's A equals K times the square of R. We're given that, again, the same old boring numbers. R is 2, A is 20 when R is 2. So we plug in 20 for A, 2 for R. We get this equation, and we easily solve to find that K is 5, so that we can rewrite our proportionality for the specific situation as A equals 5R squared. Now, if R equals 9, what's going to be the value of A? Well, we just plug in R equals 9, we get A equals 5 times 9 squared. That turns out to be 405. Okay, the next question is what happens when R gets bigger? Well, if R gets bigger, then R squared gets bigger. And that means that 5 times R squared has to get bigger, which means that you get a bigger A. So bigger R gives you bigger A. Not only that, but, well, we'll get that. Okay, now, question then is, what happens if we double R? So you should think about that if you don't know, but if we double R, what's going to happen? If we double R, that's going to quadruple R squared. So if R gets twice as big, R squared is going to get 4 times as big. That means that A is going to get 4 times as big. And I said doubled Y here, it should be doubled A. I'll fix that in a second. Okay, so, and 4 times as big, well, it means A is going to then quadruple. But one of my students many, many years ago, when I asked for the word, what happens if, you know, R doubles, he said that it's fourples. Couldn't think of the word quadruple. And I thought fourple was a pretty good word. Sounds mildly naughty, but you can put your own connotation on it. Okay, but I like to use the word fourfold. I've liked that word ever since he invented it. Okay, I'm gonna fix this and then go on. Okay, that said fourfold Y. It's really fourfold A. Another level we can see is, let's just do an example. If you double 3, you get 6. So if R changes from 3 to 6, what happens to R squared? Well, is 6 squared double 3 squared? Now check it out. What is 6 squared? What's 3 squared? Is the result double? No. Double of 3 squared is 18, right? 3 squared is 9. Double 3 squared, you get 18. 6 squared isn't 18. 6 squared, in fact, is 36. So, no. If you double R here, you're not going to double R squared. Okay, doubling a number doesn't double its square. In this case, of course, 6 squared is 36, 3 squared is 9, and 36 is 4 times 9. So, doubling the number you're squaring gave us 4 times the result. You can double any number. Square the original number, square the double number, divide it out, you're going to get 4. Another question, D is inversely proportional to L squared. Same line of reasoning. P inversely proportional to Q means P equals K over Q. If D is inversely proportional to the square of L, then D is equal to K over L squared. And that's what we get for that question. I have an etc. down here. You can plug in the numbers. In this case, it would be 2 and 20 again. And evaluate K. L squared, if L's 2, that would be 4. If D is 20, then you'd be multiplying 4 by 20. Your proportionality constant would be 80, so D would be 80 over L squared. And then whatever other value of L is given, you plug it into that equation. And that should be pretty obvious.